Hi guys, before you watch this, you can go to your Edline, and if you go down to your assignments, if you'll open up assignments, the very top thing should be BC Calculus Chapter 4 Part 1 test or something like that. You can go ahead and grab that document if you want, pull it up on your computer so you can follow along with me or print it out or whatever you want to do with it. Now I just want to walk through this real quick. If you have any questions about how I did something, maybe you can post a comment underneath the video or come in tomorrow morning for class or something like that. But just wanted to see you. This is a test. I wanted you to see me work the test I gave last year. And so the first question here is simply asking us, find an antiderivative for x squared plus 3. Anytime you don't see numbers on the bottom and the top, you better put a plus c on your answer. So this is x cubed over 3 plus 3x plus c. Okay, and the second one is a recognition for a Riemann sum all the way out to infinity. I can see here that my delta x is 3, so I'm going from 3 units apart. If I plug in n for I, I'm going to get 3n over n, which is just 3, and so that I know that I have stopped at 3. And since my delta x is 3, I'm going from 0 to 3, and what's happening to these endpoints? They're being squared. So that represents the definite integral from 0 to 3 of x squared, and I actually have to calculate this. So this means I have to go find an antiderivative. Notice the directions didn't just say, find the antiderivative or what it represents. We actually have to find this value. So I find an antiderivative between 0 and 3. We plug in 3, and it gives me 27 divided by 3, which is 9, and then we plug in 0, so we just get 9. Alright, my next question that I have to do here is a trapezoidal approximation for a function. I've got values in the table, and the trapezoidal approximation is given to me as 52, and I have to go backwards and find this missing function value. So let's find this by setting up our trapezoid approximation. So the first trapezoid would be base 1 plus base 2 divided by 2 times the width. The second one is going to be base 1 plus base 2 divided by 2 times the width. And then the third one is going to be base 1 plus base 2 divided by 2 times the width. And I know that all of this equals 52. So let's simplify this a little bit. 4 plus k plus 8 plus 20 equals 52. So 2k is equal to 3220. So k has a value of 10. Alright, next question. I've got another table here, time in hours, velocity in miles per hour. And I've got to use a left-hand Riemann sum with 5 subintervals to find the approximation of the total distance traveled. So I'm going to do my velocity at 0 times the width of that interval, which is a half, plus my velocity at 1/2 times the width of that next interval, which is also a half, and then plus my velocity at 1 times the width of that interval, which is still a half, and then plus my velocity at 1.5 times the width of that interval, and finally plus my velocity at 2 times the width of that interval. So we'll just go through here. 16 plus 15 plus 8 plus 11 plus 10. And so that's going to give us 31, 39, 50, 60. 60 miles. Okay, next one. I actually have to calculate an antiderivative and go through the fundamental theorem of calculus. So I've got to find the antiderivative for 1 over x cubed, and that is negative 1 over 2x squared. And I'm going to evaluate this between 1 and 3. So I plug in my 3 minus, plug in my 1. And I get negative 1/18 plus 9/18, which is 8/18, which is 4/9. Alright, next question. Particle moves along the x-axis. Velocity is given by a certain function. I've got an initial condition of x equals 7 when t equals 1. I've got to find the position of the particle at t equals 2. So what I'm going to do here is I'm going to find an antiderivative for v of t. Put a plus c in my little answer. I'm going to see if I can't go back and find my position. So my antiderivative here is 4t minus, what's that going to be? 2t cubed? Let's see if that works. I'm going to take my derivative real quick. 4 minus 6t squared, yes. And then plus c. There's my antiderivative. Now I know that my position at 1 has to work out to be 7. So let's plug that in. 4 times 1 minus 2 times 1 cubed plus c is 7. So that means that my c is 5. So I know my equation for my x-coordinate. It's 4t minus 2t cubed and then plus 5. So what I can do now is I can find the position of the particle at time 2. And so I'm going to get 8 minus 16 plus 5, which is negative 8 plus 5, which is negative 3. Alright, next question. I've got to find the value of the integral from 1 to 3 of f of x dx, and using some other information here. Oh, and looky here, f is g's derivative. So that means that g is f's antiderivative. So according to the fundamental theorem of calculus, this is g of 3 minus g of 1. G of 3 is going to work out to be 9 minus 9 is 0 plus 4 is 4. G of 1 is 1 minus 3 is negative 2 plus 4 is 2. So I believe this is going to work out to be 2. La 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 la. Okay. Next question requires use of the calculator. At least some of the questions require a calculator. To answer question 8 here, I've got to find the derivative of an integral. So that's the fundamental theorem of calculus part 2. The derivative and integral cancel each other. 5x goes in for the independent variable. So my answer here is 5x cubed minus 4 times 5x. So I've replaced 5x in for t, and then I've multiplied all of this times the derivative of that upper limit, times 5. Next question, the value of an integral. This is properties of integrals. So I need to do the integral from 0 to 5 of 3 plus 2 times the integral from 0 to 5 of f. I had a question like this on your quiz that a lot of you missed. I think it was on the first page, bottom right. But the integral from 0 to 5 of 3 is, I've got the line y equals 3 from 0 to 5. It makes a little rectangle, and that area in there is 15, or you just do b minus a times that function value. So this is 15 plus 2 times the integral from 0 to 5. The integral from 0 to 5 is going to be the summation of these two integrals. So from 0 to 5, that integral is 10. And so that answer is 35. My next question is asking about a tank, and in this tank I've already got some water, and for the next 6 minutes water flows out of the tank at a rate of blah 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 gallons per minute. How many gallons of water are left in the tank at the end of the 6 minutes? So here I've got to find out how much water has gone out and subtract it from here, but I got to know what limits to put in on my calculator. So I'm going to set this up. Say the integral from 0 to 6 of 9 sine of the square root of t plus 1 dt is equal to the volume, my dog's getting yelled at in there, the volume of the water at 6 minutes minus the volume of the water at 0 units. And so what I'm going to do is I'm going to find out what this value is on my calculator, and v of 6 1 second. Hold on. I'm getting. Hope I can pause. Alright, so we're back here. And I've got to fix something as well because what I'm writing down here doesn't make any sense. Back to here. Okay. If I scroll down here, this right here is going to give me how much water flows out of the tank between 0 and 6. This is like, I don't know, I don't really like this notation. I'm going to write down, because I can't just say it's the volume. It's going to give me how much water has flown out, or the difference in the heights maybe, I guess. Get my pen here. So my calculator tells me that this is 45.031. This is how much has gone out of the tank between 0 and 6. I'm really not happy with that notation right there. But this tells me how much has left the tank. Now, since I started with 81.637, then how much water is left in the tank is going to be 81.637 minus that integral. And I'm getting 36.606. Alright. Sorry about that little mishap there with my notation. Alright, next question. I've got water sprayed on the field of vegetables at that rate. I got to figure out the average rate of water flow in gallons per minute. So since that is the rate and I want the average rate, I'm going to use my formula, integral from 0 to 4 of r of t dt divided by 4 minus 0. And that works out to be 14.691 gallon, and it's got there my units, gallons per minute. Okay, next question. I've got to find the value of f of 4, and so I know the integral from 1 to 4 of f prime of x dx is equal to f of 4 minus f of 1. This integral plus f of 1 is going to give me f of 4, so I'll know that f of 4 is equal to f of 1, which is 7, plus that integral. I'll get that on my calculator, and this all works out to be 8.049. Alright, and then the next part of this my table didn't copy over. They were questions about the integral, so I'm just going to make one up real quick. So I'm going to have a 0 here. I guess I'll need a 5, and I'll need an 8, and I'll need a 12. And I'm just going to make some stuff up here. So I'll call this area 6, I'll call this area 4, and I'll call this area 5. The integral from 0 to 12 is going to be 6 minus 4 plus 5, so that's going to be 7. The integral from 12 to 0 is going to be the negative of the integral from 0 to 12, so that's going to be negative 7. And the integral from 5 to 8 is going to be negative 4. Okay, so I hope you're okay. I feel a little bad about the little water problem here. I'll come back to that. And my notation, I really am unhappy with how I wrote that. But if you integrate if you integrate a rate, you get the change in the flow. So you know that this integral tells you how much water has left the tank. So you subtract it from how much was in there. I'll work on that notation better. So I hope it helped a little bit.